Good morning everybody, this is another flip lesson we're looking at today is decision making in skill acquisition, and we're really going to be focused on reaction times, response times and movement times. Usually we refer to it always as reaction time, but there's a lot more to do with reaction time, as we will see. So as you've come to love, I've added in here our specification so we can see what we really want to focus on. And today the focus is on obviously decision making here, but we've also got, once we've covered the decision making, we're going to look at anticipation and factors that affect our reaction time. A lot to get through and a lot of definitions in this area. Okay, so let's start off with looking at the definitions of what make up reaction time, response time and movement time. They're the key things to this area, so let's make sure we understand the terms completely. And obviously we need to figure out why reaction time is important. So let's think about reaction time on a graph. So what we have here is the line is representing time taken. And you'll see similar sort of graphs like this in exam questions. And what we need to do is look at how this is defined, how this works out to make the definition of reaction time. So the key to understanding reaction time is to know the word a stimulus. And in PE we refer to this as the presentation of a stimulus. So we have our presentation of our stimulus here on our graph, so you can see it. Now, as soon as we receive the information from the stimulus, we have to make a decision on it, and usually refer to this as the reaction time. Now, the reaction time is the time taken from the start of the stimulus, the presentation of the stimulus, to the start of the movement, which is here. So next what we have is the time from the start of the movement, which is, as we know, is this line here, to the end of the movement, which is this line over here. And we refer to this as movement time. So that is start of the movement to the end of the movement. Finally, we have the response time, which is basically the time from our start of our presentation of our stimulus all the way to the end of the movement, also known as reaction time plus movement time. So let's get rid of these pictures and add in an example. The obvious being a 100-meter sprint. Often the exam questions like to use a swimming start in a sprint swimming race, but it's the same thing for 100-meter sprint. So what we have is the presentation of stimulus. So in terms of that respect, the presentation of stimulus is, you're right, the gun, or the buzzer if it was swimming. Now we have the reaction times, the time taken from the brain to process the information and make its decision, to the movement. Now the movement is the start of the contraction of the muscles, where you start to contract your quadriceps and gastrocnemius to try and push off the blocks. So that will be the start of the movement. The end of the movement is once we've left the blocks and we've finished pushing out of the blocks and taken our first stride. Sometimes in some exam boards and some textbooks we might refer to the movement, end of the movement, as when you complete the race. So the overall response time is the start of the stimulus, the presentation stimulus, which is the gun, to the end of the movement, which is the first stride of the sprint start, or alternatively could be the end of the race. So let's just drop these words in here on the graph. So we've got our gun, there's the start of presentation of our stimulus, we have the push of our blocks is the movement, and then at the end of the movement would be the end of the stride. Put all of those together, what we have is response time. The good news is we have two more definitions that you need to learn for your exams. Simple reaction time and choice reaction time. So we've got two pictures here, one showing some sprints, a sprint start, and another showing a basketball example. And what I want you to do is think right now, how can we define simple reaction time and choice reaction time? Use the pictures to try and help you answer that question. pause if you need to pause. Okay, so we're going to add in another clue. So there we have it, an extra clue for you. Pause if you need to pause, if you need to try and figure out what they are. Simple reaction time is where we have one stimulus and one response possible. So in the example on the picture, we have one stimulus, which is the sound of the gun going off, and the one response, the start of the sprint race. Choice reaction time is where we have two or more stimuli and two or more possible responses. So in this respect, we have a basketball player, and you have the stimulus is obviously the ball, the net, the player trying to challenge him here, another player trying to challenge him here, and we have a number of responses that could go with it. So you've got obviously the shot, you also got the player who could receive the ball here, player who received the ball here, and it increases the possible outcomes. So we've got two different definitions: simple reaction time and choice reaction time. Along with most of the exam questions in reaction time area, they want you to define a term. So it could be just define movement time, define response time, also simple reaction time and choice reaction time, and they usually want a sporting example to go with it. Please excuse the sound of my son in the background.
Reaction time is the time taken from the beginning of the stimulus to the start of the movement or response. Movement time is the time from the start of movement to the end of the movement. Response time is the time from the start of the stimulus to the end of the movement.
Came off a boot and then it sort of went all over the place, and now it's Weepu with the kick. Quade Cooper gets back there. Now he's got Corey Jane. No problem there. Dummying.
We need someone with him. Oh, what about this little bit of magic? Up you go, there you go.
Oh, you don't see that in some of the best nightclubs in Sydney.
Look at Tony Woodcock hoping like hell he'd pass the ball so he didn't have to confront that.
So you've watched Quade Cooper sidestep Corey Jane in the rugby example. Why did Corey Jane fall for the sidestep? And reaction time comes heavily into that. One of the theories is Hicks' law, which is used to describe why when we have an increase in stimuli available, it takes us longer to make a decision. So reaction time is increased, which means the time doesn't get faster, it actually gets slower. So we talk about reaction time increasing, and as you can see by the graph, it's a positive linear graph there to depict the more stimuli there are, the longer it takes to respond. Applying that to Corey Jane and Quade Cooper, as Quade Cooper goes one way, steps one direction, that's sending a stimuli, he's stepping another way, he jumps in the air just beforehand, and all these stimuli make it harder for Jane to respond, and he slows down his decision making, and therefore the dummy is played. An explanation for Hicks' law relates to a theory called single channel hypothesis, and it looks like this in books and sometimes in exam questions. The principle of the theory is that we can only process one piece of information at a time. So let's show you how that looks. So it looks like a bottleneck approach. If we have two pieces of information being processed at once, the first bit of information will move down, the second piece of information will move down, and at the bottleneck they can't be both processed at the same time, so we have to allow one piece of information to be processed before we can deal with the next piece of information. And this is essentially single channel hypothesis. In other words, there's only one channel and we can only process one single piece of information at a time. The reason why it took Corey Jane so long to respond is that Quade Cooper's first piece of information that he presented to Jane was the dummy, the sidestep, and then he changed direction, which is the second piece of information. So the first piece of information has to be processed before we can deal with the second piece of information. The next and more complicated explanation for the delay in reaction time can be linked to a theory called psychological refractory period, also referred to as PRP. This theory is used to explain where a performer may send two stimuli, one after the other, in order to fool their opponents. Based on the single channel hypothesis, the first stimuli may be presented, and that needs to be dealt with before the defender, can move on to the second stimuli. We've got this term stimulus onset asynchrony, which it doesn't show up in the exam questions, it's just part of this diagram. It means the time between the first stimulus and the second stimulus. Using the term stimulus and response, I'll explain it. So we have the stimulus 1, which would be the initial side step, so the movement of going one direction. This stimulus will need a response, so we have response 1, which will be the player going towards the direction of the side step. So the attacker now pushes the other direction quite close to the first stimulus. He's thrown in stimulus 2, so we've got stimulus 1 closely followed by stimulus 2. This also requires a response. We'll call that response 2. Now, based on the single channel hypothesis, the defender can't move to response 2 until they've cleared response 1, so therefore there's a delay in the time taken to respond to the initial or the second movement. This delay, referred to as slack on the diagram, is actually called the psychological refractory period, and it's used to explain why players make mistakes when an opponent has dummied them or sold them a fake of some description. I want to give you a practical example to try and understand the psychological refractory period. So let's just watch this video of Shane Warne and a bowl that he did, often referred to as the ball of the century. If we watch it again in slow motion, you can see how the psychological refractory period works. So the ball will come and it will move in this direction, it will hit the floor about here, and then it will change direction this way. The stimulus 1 is the ball moving to here. The response that the batsman does, he steps to play it here. Now, as the ball takes the spin off the ground, it changes, and we have stimulus 2. The batsman is still processing stimulus 1 before he has a chance to process stimulus 2. Let's watch it. Stimulus 1, response 1, stimulus 2, delay in reaction, psychological refractory period. This is often used in exam questions, so make sure you read up on this one as well, and we'll look at it in class in more detail.